Today we are doing Bruce's topic. We're going to start to look at statements. So in maths, you have a statement. It's called a proposition. So a proposition can either be true or false. Square root 4 equals 2. It's a proposition. Is it true? So that is a true proposition. 3 equals 2. Is that a true or false proposition? False. Pi equals 22 over 7. False. They can either be false or true. They can't be both. Write it down. They can't be both. It's either true or false. Can't be kind of. There's this thing called or. So you can have something that's, let's call it A or B. So it's going to be the A thing or the B thing. So it's Friday or Saturday. Okay? And it includes both. So it includes both. You can have the opposite. It's not really the opposite. A and B. So it has to be both. Includes both. So it can be either A or B or both. This one, it has to be both. So it has to be A and B. So I'll give some examples. So you're going to get a fine if it's red. You're not going to get a fine if it's green or orange. Okay, so A is green, B is orange. When you go through the light, it can be A or B. And statements. So it has to be and. I'm going to go with animals. So I've got a whole bunch of animals in my... Have you been to the circus? Like a fete? And it's got like the rabbits and the goats and the chickens in the playpen. So I'm going to pick an animal. And I want the animal to be a rabbit and white. Okay? So it has to be a rabbit that's white. If I pick up a rabbit that's black, it doesn't fit A and B. It does fit A or B, yes. So if I pick up a rabbit that's black, A or B works. If I pick up a rabbit that's black, A and B doesn't work. It has to be a rabbit that's white. So A is the rabbit event, B is the white event. Does that make sense? So you can express this in terms of Venn diagrams. So you did this last year. You got all the A things, all the B things. So when it's A or B, what do we do with the Venn diagram when it's A or B?
Everything inside of them.
Everything.
I would like to
A and B. Where's that? Someone else. Do you remember last year's Venn diagrams? It's the bit in the middle.
Intersection.
Correct. We also have this new diagram. It's called a truth table. Shh. So I'm going to use a truth table. I'm going to give you an example. Today is Sunday and the weekend. So you might express it as S and W. Sunday, weekend, Sunday, and the weekend. So if it's Sunday, it's the weekend, it's true. If it's Sunday, but it's not the weekend, it's not true. If it's Sunday, the weekend, it's false. And if it's both false, then it's false. For and or for a Venn diagram. Union, the upside down U, and intersection. So can you copy this down? Have a go at expressing it as a Venn diagram. I will make a start while you're copying it down. So A is multiple of 3.
What's the name of the whole set, sir? What symbol do you use for that?
The universal set,
Yeah.
psi,
Okay, how do you do it?
to backwards,
So many times.
3 with a little tail. Or an E, loopy E with a tail. So this is the universal set, these numbers. So this circle is A, this circle is B, where A is the multiples of 3, B is the even numbers. So you put all the ones that are multiples of 3 but not even in here. So what's a number that's a multiple of 3 that's not even between 1 and 10? Correct. You put all the numbers that are not multiples of 3 and even in here, which are 2, 4, 8, and 10. What is the numbers that are both a multiple of 3 and even? 6. Very good. Now, there's numbers that don't fit either category. Where do we put those? In the bin, which is outside the circles. 1, 7, 5. Perfect ordering. Okay, so we got 2 in here, 1 in here, 4 in here, 3 out there. You can also express A like this. Have you seen the squiggly brackets? So what's in A? So don't forget to include the number that's in both. A union B is all of those. 8, 9, 10. So it's everything in both. All of those are union A, B. A intersection B, what's that? It's just the middle bit, very good. And then you can do the universal set, which is all of those numbers, 1 to 10. The last topic for today is negation. So you guys are familiar with this symbol? Yeah, what does that mean? Not. So this means not A. So that is for Venn diagrams. That's for Venn diagrams. For proofs, you have this symbol, which also is not A. And this is what negation is. So it's just whatever not A is. So if A is an even number, what is not A? Odd number, very good. So we can do an example of this. So this is 3 is greater than 8. What's the negation of that? 3 is not greater than 8. So 3 is less than 8. I'll just show you this as a table. It's pretty straightforward. So if A is true, not A is. This is the truth table. If A is false, not A is.
True.
Yeah. just in case it wasn't obvious.